Just now we have studied the trend of atomic radii ataupun the radius of atom. Okay, so now I would like to discuss about the variation in ionic radii. Kenapa jadi ion? Sebab dia ada charge sama ada positif atau negatif. Dia bukanlah neutral atom. So if let's say you observe the graph here, this is going down the group, kan? Kalau going down the group, supposedly size makin lama makin besar lah, kan? So this is actually size of the atom in down the group, okay? Tapi bila dia jadi ion, okay, sebab kan group 1 kan dia suka metal kan? Metal dia suka donate satu elektron sebab dia ada satu valence elektron kan, group 1. So that's why dia suka donate satu elektron, that's why dia jadi ion, okay? So jadi ion pun jadi cation. If you look at here, it can be concluded that bila proton number increase, atomic radius pun akan increase, the size of the atom will be increased. Same goes to the ionic radius. Okay, bila let's say proton number increase, the ionic radius pun will be increased too. Why? Okay, why? Okay, macam mana ion terbentuk? Ion terbentuk bila sesebuah neutral atom sama ada dia accept elektron. Bila dia accept elektron, dia akan jadi negative ions kan, ataupun dia dermakan elektron. Bila dia derma elektron, jadi positive ions. So there is actually the variation in ionic radii. So the first one, I will talk about the size of positive ions, and the second one, I will talk about the size of negative ions. One of the syllabus di dalam periodicity ialah you need to know how to compare the atomic radius of an element corresponds to its ionic radius. You kena compare atomic radius bersama dengan ionic radius masing-masing, okay? Okay, so let's talk about the size of positive ions. Bila kita bercakap pasal positive ions, it is when a neutral molecule donate elektron kan, sebab bila dia donate elektron, dia buang elektron, saiz dia makin besar ke makin kecil? Mestilah saiz dia makin kecil sebab dia donate elektron kan. So when electrons, macam mana dapat positive ion? Sebab bila electrons are removed from an atom, okay, saiz dia akan kecil. Sebab kenapa? Inilah penjelasan dia. Kenapa saiz dia kecil? Sebab ZF akan increase. Kan Miss bagi tahu, kalau let's say saiz sesuatu saiz elemen tu kecil, you guna point ZF. Okay, kalau saiz besar, you guna point shielding effect. Same goes to positive, tapi in neutral atom lagi panjang lah dia punya penjelasan dia. Tapi kalau you nak compare the size of atom dengan size of daripada size of ionic radius dia, if let's say you dapat positive ion, sebab apa? Sebab atom tu dia remove electron. Bila dia remove electron, the repulsion between electrons akan decrease. So bila the repulsion decrease, therefore ZF, effective nuclear charge, akan increase. Okay, so bila effective nuclear charge increase, the remaining electrons yang dah tinggal tu, dia akan makin lama makin dekat, tertarik dengan nukleus. Dia punya force of attraction dia akan lagi dekat dengan nukleus. So bila force of attraction between electrons dengan nukleus ni makin lama makin stronger, and then makin lama makin dekat, the electron cloud will shrink. Electron cloud tu akan daripada besar, lepas tu sebabkan satu elektron you remove, so makin lama makin shrink dia, ya, makin lama makin dia mengecil. So that's why cation. Kenapa cation? Sebab cation adalah panggilan for a positive ion. Hence cation is smaller than its atom. Okay, that's how you bagi explanation bila soalan suruh kamu compare the size of ions dengan comparekan dengan atom mereka. Okay, Okay, kan Miss cakap tadi, kalau let's say kamu nak compare the size of positive ions, comparekan dengan dia punya atom masing-masing. Okay, kenapa size of positive ions ni kecil daripada atom dia? Kenapa? Sebab ZF value will be increase. So bila ZF value increase, bila jadi positive ion, makanya size dia pun akan mengecil. Okay, bila ZF increase, the size will be decrease. Okay, so if you tak percaya, you boleh buat mathematically here. Okay, so if let's say you ada sodium atom, okay, this is sodium atom. Bila sodium atom, bila dia jadi ion, okay, sodium atom because dia punya valence electron ada satu kan, so they happy to remove this one electron so that dia akan jadi sodium plus ion. Okay, so bila jadi sodium plus ion, maka hilanglah 3s1. So if let's say you nak kira ZF of sodium atom, ZF of sodium atom, the proton number of sodium kan ada 11. Tolakkan dengan inner electrons. Inner electrons adalah, this is inner electrons. Okay, so the inner electrons, the number of electrons di dalam inner electron ada 10. So 11 tolak 10 jadi positive 1. Kalau let's say you ada sodium plus ion, kenapa dapat sodium plus ion? Because dia remove, dekat atom ni dia remove satu elektron, jadilah 1s2, 2s2, 2p6. Okay, so if you want to find the ZF untuk sodium plus ion, it will be proton number of sodium still 11. Proton number still ada 11, bukan electron number, proton number 11 minuskan dengan inner. Okay, since this is, bila dia remove satu electron, so this will be the valence electron untuk sodium plus. Okay, therefore this will be the inner electron, will be S. Okay, so 11 tolak 2, positive 9. Okay, so you nampakkan ada perbezaan yang ketara untuk effective nuclear charge for sodium atom corresponds to its ionic ionic punya effective nuclear charge. Okay, which is positive 9. So bila ZF value increase, bila dia jadi positive ion, therefore the size will be decreased. So that's why lah the size of the ionic radius of Na plus compared to sodium atom smaller. Okay, sebab apa? Sebab dia ada positive ions. Same goes to calcium juga. Calcium dia punya valence electron for S2, dia berada di grup kedua. Kalau metal group, dia memang kalau metal group selalunya cation sebab dia orang happily to remove the electrons. Okay, so bila dia remove this, dia akan jadi 3s2, 3p6. Therefore, this will be the valence electron and this will be the inner electrons. Okay, so if let's say calcium, bila dia jadi positive ions pun sama juga. ZF untuk calcium 2 plus will be higher compared to ZF untuk calcium atom, neutral atom. Okay, same goes to aluminium. Aluminium dia dekat transition metal. Again, if it's transition metal, dia suka remove electrons. Okay, dia happy to remove electrons. So bila dia remove 3 electron, dia akan jadi Al3 plus. So the electronic configuration dia akan jadi 1s2, 2s2, 2p6. Okay, so sekarang ni this will be dia punya valence electron and this will be dia punya inner electron. Okay, tapi sama je, bila Al3 plus, dia punya ZF will be higher than Al atom. Okay, Al neutral atom. Therefore, you know lah, size of positive ions ni, size dia kecil sebab apa? Dia punya ZF, dia punya effective nuclear charge increase compared to its neutral atom. Okay, And one more thing, bila let's say mereka ni dah jadi positive ions kan, masing-masing ada electronic configuration of noble gas. Okay. Okay, what happen kalau kamu nak remove electron dekat transition metal? Kalau kamu nak remove electron dekat transition metal, as what I told you guys earlier, you need to remove it from the s orbital. Okay, remove it from the ns orbital dahulu, barulah kamu remove from the n-1d orbitals. Contohnya, if let's say you ada iron with this electronic configuration 4s2 3d6. Right, but you need to remove the electron. If let's say you nak jadikan Fe kepada Fe2+, you need to remove the electrons from the 4s dahulu, barulah 3d. So electronic configuration of Fe2+ will be Ar 4s0 3d6. Kiranya yang ni tak ada lah, non-hador sebab dah remove. What if let's say you Fe3+? Kalau Fe3+, you have to rujuk the electronic configuration of its neutral atom. Okay, so neutral atom ada Ar 4s2 3d6, but you nak remove 3 electron. Kenapa dapat Fe3+ is because you want to remove 3 electron. So nak remove 3 electron pun starts with removing it from the s. Okay, remove daripada s dahulu baru d. So in this case you nak remove 3 electron, so remove 2 electron daripada 4s. Tak cukup pinjam electron dekat 3d, pinjam 1 sahaja. So that's why you will get 4s0 3d5. Okay, so 4s ni tiada lah, sudah tak payahlah tulis 4s0 sebab dia dah tiada kan. Same goes to Mn, manganese. Manganese have this electronic configuration. Manganese adalah dalam transition metal juga. Kalau transition metal mesti ada dia punya valence electron 4s dengan 3d kan. Again, kalau if let's say manganese nak jadi Mn2+, that means kenapa dia dapat charge Mn2+, because they remove 2 electron. Okay, so nak remove 2 electron kena rujuk pada dia punya neutral atom first. So the neutral atom ada 4s2 3d5, therefore bila you nak remove 2 electron dekat Mn, nak form, sebab you nak form Mn2+, so you will have 4s0 3d5, tapi dah jadi 0 ni tak payahlah tulis. Okay, so macam itulah kalau kamu nak form a positive ions dekat transition metal. Okay, remove dahulu dekat 4s, baru kalau tak cukup baru ambil dekat 3d. Okay. Next, let us discuss about the size of negative ions. Okay, usually atom tu dia dapat jadi negative ion sebab atom ataupun elemen tersebut adalah non-metal. Ya, non-metal. So basically, kalau let's say dalam periodic table of elements, if let's say you ada periodic table of elements where you have S block, P and D block, S block dengan D block, kedua-duanya ni kebanyakannya adalah metallic elements. Alright, P block kebanyakannya non-metal elements. So P block kebanyakannya akan carry charge negative. Okay, so dia happy nak accept electron. S block, metal block, dia suka donate electron. So that's why kalau S dengan D block kebanyakannya metal elements akan, bila let's say dia remove electron, they happily to be a cation ion. Alright, so negative ion size dia always larger daripada dia punya neutral atom. So if you look at here, if let's say you ada non-metal F non-metal kan, with this electronic configuration 1s2 2s2 2p5, so this is the punya valence electron kan. So 2 campur 5 7, untuk jadi octet kenalah accept 1 electron. That's why bila dia accept 1 electron, so dia jadilah F minus sebab dia accept 1 electron. So bila you nak tambah electron, if let's say ada DP block which dia punya valence electronic configuration-nya adalah NS dan juga NP, make sure you add it dekat NP dahulu ya, baru NS. So bila let's say dia jadi accept 1 electron, dia jadi F minus, Therefore, dia punya electronic configuration dia pun akan berubah jadi 1s2, 2s2, 2p6. Okay. Alright. Kenapa negative ions ni always larger dan dia punya size neutral atom? Because negative ions have more electrons daripada dia punya neutral atom, sebab dia gain electron sebab nak form negative ions, right? Okay. So untuk tahu explanation later, we'll go for next. Okay, the perfect explanation of why negative ions is larger daripada dia punya atomic radius is because of bila you add the electrons, repulsion pun akan makin lama makin bertambah, kan? So kan bila I bagi tahu you, shielding effect terjadi bila ada electron repulsion between the same shells, tapi tak sekuat lah between different shells. Okay, bila let's say electron tu ditambah, makanya ada pertambahan repulsion. Repulsion between electron increases. So bila repulsion bertambah, therefore shielding effect between electron pun bertambah. Okay, so bila shielding effect bertambah, dia akan affect the attraction between nucleus and the valence electron. Makanya because of this repulsion, because shielding effect increases, therefore electrons akan jadi less attracted to the nucleus. Okay, dia akan jadi less attracted, so dia makin lama makin jauh, macam tu. Therefore the outer orbitals will be expand. Alright. ZeF tak main peranan pun in negative ions. Okay, kalau positive ions, ZeF main peranan. Okay, kalau negatif, kan Miss bagi tahu kalau let's say size tu kecil, sebab ZeF main peranan. Size besar sebab shielding effect. Okay, sebabkan shielding effect, attraction pun berkurang, makanya that's why outer orbital expands. Therefore an ion is larger than its atom. Alright. Tadi kan kita dah bincang before this, kalau size of negative ions, kenapa size dia mengecil? Sebab shielding effect. Okay, because shielding effect increases. Tak main lah ZeF. ZeF tak main. ZeF effective nuclear charge remain the same. So if let's say you tak percaya, you boleh kira ZeF untuk neutral atom dengan ZeF effective nuclear charge bila dia jadi negative ion. So if let's say Miss ambil contoh lah for oxygen. Okay, kalau oxygen dia punya valence electron berada pada 2s2, 2p4. Sama lah juga kalau let's say you remove you accept electron pun you akan accept dekat 2p, kan? Sebab kenapa accept? Sebab itulah charge dapat O2 minus, because you accept 2 electron. So bila nak accept, you kena accept dekat valence orbital, okay, which is in this case ialah 2p. Alright. So kalau let's say you nak juga kira ZeF untuk atom with its ions, with its negative ions. So for neutral atom oxygen, the ZeF will be positive 6 because proton number untuk oxygen 8 tolakkan dengan inner orbital, inner shell 1s2. Okay, so dapat positive 6. Alright, kalau let's say you nak kira ZeF effective nuclear charge untuk O2 minus, the proton number still the same, which is 8, minuskan dengan inner orbital. Inner orbital dia sama, tak ada perubahan pun. Okay, so because dia punya effective nuclear charge remain the same bila dia jadi negative ion, therefore you tak boleh guna point ZeF, you kena guna point shielding effect. Okay, so kenapa negative ion kecil? Sebab dia punya effective nuclear charge remain the same. The shielding effect akan bertambah bila let's say you tambah, you accept electron, makanya akan bertambah repulsion of the electrons in the shell. Therefore shielding effect pun akan bertambah. Bila shielding effect bertambah, attraction between electron and nucleus makin bertambah. Makin bertambah ke dia punya nucleus? No. Bila shielding effect bertambah, the attraction between electron dan nucleus makin lama makin weak. Bila makin weaker, dia punya orbital will be expanded Bila orbital dia expand, therefore the size of negative ions will be bigger than its corresponding atom. Okay. Okay, kalau let's say negative ions, dia punya negative ions ni, dia punya electronic configuration dia pun akan dapat sama dengan noble gas bila dia jadi ion. Okay. To conclude, the size of cation kan, the size will always be smaller compared to its atom, while the size of anion, ni size of anion kan, size of anion will always be larger compared to its atom. Alright.